Today, I'm going to be showing you the relationship between linear and angular velocity. So stay with me. Now, the first thing you need to understand is that angle can be measured in degree, it can be measured in radians, and it can be measured in revolution. But a lot of students know that angle can be measured in degree, but they don't know that angle can also be measured in radians and in revolution. So first thing is that let us show the relationship between the three of them. So 360 degree is the same thing as 2 pi radians and is the same thing as 1 revolution. Now, 360 degree is the same thing in radians as 2 pi radians, and in revolution it is 1 revolution. I hope you still have an idea of what 360 degree means. So if you have a circle like this and a body travels around a circle like this once like this, so we say the body has moved 360 degree, right? So that is 360 degree. Now this 360 degree in radians, it is 2 pi radians. Now in revolution, it is 1 revolution, and you know that 1 revolution is when a body moves around a circle once like this. That is 1 cycle. You understand? So that is 1 revolution. Now, sometimes you may need to do conversion between these three also. That is, you may be given the angle in revolution, and in your calculation you will need to use radians. So if you know this, then you should be able to do your conversion. For example, how many radians do you have in 2 revolutions? So once you know that 2 pi radians is 1 revolution, right? Revolution, then how many radians will give you 2 revolutions? Then you can be able to do something like this, and then you're going to know that your x is going to be equals to 4 pi radians. Note that without doing this, once I know that 2 pi radians is 1 revolution, then I will know that 2 revolutions should be 4 pi radians. But I'm just showing you, in case you don't have small numbers, you have like decimal. So this is how you do your conversion. Do you understand? Sometimes you may be given degree and you need to convert it to radian also. So this is just the way to do the conversion. Do you understand? For example, how many radians do you have in 180 degrees? So once I know that 360 degree is 2 pi radians, then 180 degree will give me what? Will give me x, something like this, and then you cross multiply. You realize that your answer at the end of the day is going to be pi what? Pi radians. So that is the way to do your conversion. So once you know this, then you'll be able to do any conversion you want to do. Now, having known this, then the next thing we're going to be doing is to be showing ourselves the relationship between the linear and angular velocity. Now, and I'm going to use what we already know to do that. Now, let us draw a circle like this, everyone. Now, we have a circle like this. I'm going to locate the center of the circle. I'm going to draw a radius, and I'm going to draw another one. You understand? I'm going to put the angle here as theta. Now, this length, we always call this in mathematics, we say this is length of an arc from here to here like this. We say this is length of an arc. So I can use N to represent it, right? But I'm going to use S to represent it. This is physics. So I'm going to use S, and I'm going to write the meaning of that. Now, this is S. Don't forget that this is your radius. This is another radius, right? Good. Now, I'm going to write the meaning of my parameters. So R means what? Radius. Theta is equals to angular displacement. Now, this S means S is equals to linear displacement. You know, in physics, we say this S is length of an arc, right? But here, it is linear displacement. Now this theta here now, it is angular displacement. While r is the radius, right? Good. Now, having known that, in mathematics, we know the formula for calculating the length of an arc, right? So that the length of an arc, our S here, which is the length, which is representing our L. So this S is the length of an arc, and this S is equals to theta over 360 2 pi r. Remember that the whole length of the circle, which is the circumference, is 2 pi r. But this, since we are only interested in this small angle, says, okay, theta over everything times 2 pi r. So anyway, we should know that the length of an arc is equals to theta over 360 2 pi r. I think everybody knows that. Now, having known that, now what if we are interested in making this calculation in radians? That is, our angle should be in radians and not in degree. Then we can actually do something here, right? So this 360 degree, we can convert it to what? We can convert it to radians. So what we are going to do is that S is equals to theta over, now how many radians do we is 360 degree? Remember here that I said 360 degree is 2 pi radians. So anywhere I see 360 degree, I'll put 2 pi. So here I'm going to put 2 pi here like this, then 2 pi r, right? Now, you remember, you can see this down here, 2 pi. You can see this up here, 2 pi. They will cancel each other. And at the end of the day, I can say my S is equals to what? My S is equals to theta what? R. But don't forget that this is done, this calculation is done in radians. Don't forget that. Now, what if I decide to make my theta the subject of the formula? I can make theta the subject of the formula here. So I can say theta, if I divide both sides by r here, divide this by r, divide this by r, so r cancel r, and my theta is equals to S over r. So what are we saying, everyone? So we are saying that the angular displacement is equals to the linear displacement. Remember, angular displacement equals to linear displacement divided by the radius of that circle. Can you see this? Please take note of this formula. This is very important. Now, having known this, then the next thing we're going to define is that all of us should know that there's something we call angular velocity, and the angular velocity is represented by omega, right? This omega is called angular velocity. Sometimes you can say angular speed, you understand? So, but here it is angular velocity we are using. So, which is angular velocity is equals to angle turned, which is angular displacement over time. Remember that velocity is displacement over time, but since this is angular, then we are going to use angular displacement here, then over time. Do you understand that? Now, you know that my theta here, can you see my theta is equals to S over R, right? My theta is S over R. So what if I decide to replace this theta that I have in angular velocity here by S over R? That is, anywhere I see theta here, I'll put S over R, right? Remember that our time is a denominator, here is down. So I'm going to say this angular velocity, omega, equals to theta. Instead of theta, I'll put S over R, so which is S over R. But remember that the time is also down here, right? So I'll put my time, right? Now, let me cross multiply and make S the subject of the formula. So I'm going to say that if I put over 1 here and I cross multiply like this, so my S, 1 times S is S, so equals to omega RT, right? Omega RT. Can you see this? Now, I want to call this one, let me call this equation 1. There's something I want to do here, equation 1. Now, everybody should know this also, because it is something that we've learned, even like once you start physics like this. It's one of the things you first know, that we have linear velocity. So linear velocity V, also linear velocity V equals to displacement, linear displacement over time, right? Linear displacement over time. Am I right? Good. So once you know that, let me make my s the subject of the formula here also. So I can do that by saying over 1, then cross multiplying. So my s here, s times 1 is going to give me s equals to v times t is going to give me what? Vt. Do you understand? So v times t. Now let me call this equation 2. But do you know something? Please notice here that we have s equals to omega rt here. We also have s equals to vt. Well, s can be equals to s here. S is equals to s, right? If you have to say s equals to s, it means that everything we have in equation 1 can be equals to everything we have in equation 2. Because this s is this, s is also this. So we can say vt is equals to omega rt. Do you know why? Because s is this, s is also this, so this can be equals to this. That's exactly what we are doing there. So now we can divide both sides by t, because t is on both sides. So we can divide both sides by t here, divide this by t, divide this also by t. So t will cancel t, and t will cancel t here also. So we can say v is equals to, which is linear velocity, equals to angular velocity omega times radius. And this is the relationship between the linear velocity and angular velocity. Well, this question do come out most times in WAEC, in JAMB, like that. So it's something that we can know. You don't need, you can actually know how to derive that, but of course you should know the relationship. V equals to omega r. So now, in addition to that, in addition to what I've said, now let me quickly show you something. Here, remember that, okay, let me clean this. Now, remember that I told you that angular velocity is equals to theta over t, right? That is, angular velocity equals to the angle turned per unit time, right? Now, but do you know something? What is going to happen if a body moves in a complete circle like this? That is, move in a complete circle. What is going to happen if a body moves in a complete circle? What is the angle? What is going to be your angle if a body moves in a complete circle? Well, your angle is going to be equals to 2 pi. Because if a body moves in a complete circle, it means that that is a special case, which is 1 revolution, that is 360 degrees, and it is in radian, it is 2 pi. So if I'm doing my angle in, if I put in my angle in radians, that's going to be 2 pi, because I'm saying that, okay, a special case, let's say for 1 complete circle now, so my angle should be 2 pi because it's 1 complete circle, then divided by time. Now, since I'm taking a special case for 1 complete circle, which is 2 pi, then what about the time? In physics, the time it takes for a body to move around a circle once, to complete a complete cycle once like this, that is, to move around a circle once, the time it takes is a special time that we call period. It's a special time that we call what? Period. And then I'm saying period like this, period. And it is what we call, we give it capital letter T. So it is period, right? So meaning that instead of this, I'm going to put capital letter T, right? I'm going to put capital letter T. So meaning that this is a special case when the theta is 2 pi, that is, body move in a circle once, and again the time to do that must be the period of that body, or moving around the circular part must be the period, that is, the time it takes for the body to cover 1 complete cycle. You understand? So now we can say that omega here is equals to 2 pi over period, right? And you know, in this kind of question, you only need the question to give you period to calculate your angular velocity, because you know pi is 22 over 7 on 3.14. So we should start this. Please try to always remember this. It is very important. But let me tell you something. Let me tell you something. You see, this period, this period is related to what we call frequency. Period is equal to 1 over frequency. Period is equal to 1 over frequency. And or you can say frequency is equal to 1 over period. Anyone. So meaning that if I want to change this, if anytime I see period, I'll put 1 over frequency. So meaning that I can say omega will now be equals to 2 pi over, what is my period? My period, instead of period, I can put 1 over frequency, so that's 1 over frequency. So that will give me this equals to 2 pi. Remember, this division, I can change it to multiplication, right? And this fraction, I'll turn it upside down. That is going to be f over 1. So that means my angular velocity can also be equals to 2 pi f. So this formula is also very important. So please take note of this. We are talking about relationship between angular velocity, linear velocity, and angular velocity. Then you should use this. But when you are asked to calculate the angular velocity on its own, you can consider using this if you are given the period. But if you are given the frequency, you can consider using this. Thank you.